how do we go with formulation of hypothesis? What are the different types of hypothesis? As we said, null hypothesis and alternative hypothesis. We also mentioned about type 1 error and type 2 error. So in our today's class, we are going to start from type 1 error and type 2 error and slowly going towards the testing of hypothesis. Right. So we yesterday in our class, we mentioned that type 1 error is the possibility of rejecting a null hypothesis when it is true. Right. And type 1 error is denoted by alpha. Okay. So from there, we are going to start with. And type 2 error, as you know, it is a possibility of accepting the H naught or null hypothesis when it is not true. Okay. Now, today we are going to talk about something called as level of significance. It's very important for every statistical test, like hypothesis testing, we go with the level of significance. And it's nothing but it is otherwise denominated as alpha. I have put the symbol here, alpha, and it is the probability of committing type 1 error. Okay, a researcher looking into the external environment, the situations, the prevailing conditions. Based on all these, the researcher might say that yes, there is 5% chance of me accepting, me rejecting the null hypothesis when it is true. So that is the risk factor, the probability or the risk factor of rejecting the null hypothesis when it is actually true. Otherwise, it is probability of occurrence of type 1 error. Okay, type 1 error. And this probability, if the researcher is very sure with the conditions, he or she will keep the probability as 1% minimum. But if he is like into a moderate scenario, and that is how we generally find in a research, the level of significance will be 5%, which means he is saying that yes, there is 5% of chance of commission of type 1 error. That is rejection of our null hypothesis when it is true. And sometimes if the research, if the data is very very much scattered, the researcher is not pretty sure with, he's new into an area, he might keep the level of significance at a higher rate, that is 10%. In fact, when we are trading up, when we are going up, there is a risk factor that our research is not representative of the actual condition, because we are saying that I'm 10%, there is a chance that I might commit an error, reject the actual thing and accept the wrong thing, right? So that is why in the general case, in social science research, you will find researchers keeping the significance level at 5%. So that means there is 5% risk of committing type 1 error, which is denominated by alpha. Okay, so that's about, that's what I have said. If 5% is our level of significance, what we say is there is 5% risk of rejecting the null hypothesis when it is true. So this is about the level of significance. Okay, and moving further, this is something which we really have to understand. Okay, when I'm going with testing and hypothesis, I have different tests based on the different conditions, different tests based on the type of distribution. Like, I will have F distribution, T distribution, which you will learn in detail in your statistics paper. F distribution, T distribution, or maybe Z distribution. Based on the type of distribution, I would be like deciding what is the test I would be applying. Say normally in a small size test, we will be going with t-test, and if the sample size is larger, we would be going with z-test. Likewise, which you are yet to learn, but this is the theoretical perspective of what we have to understand. And when I'm saying that, okay, see, I have a possibility of setting an hypothesis that my null hypothesis, maybe I claim that the average score of students in PG class is 80. Okay, 80 marks upon 100. I make the claim like that. then there is a possibility that it may not be 100. It can be more than or less than 100. The average score can be less than or more than. But I said the claim like that. So in that case, my null hypothesis is average score is equal to 80 marks, and my alternative is not the sample mean test stat is not equal to average score of 80 marks. So there is a possibility of rejecting and accepting. Now, when I'm saying that, either the average score can be more than 80 or it can be less than 80. So there are two conditions in such a scenario. That is where we call with the case of, that is where we refer to two-tailed test. That is, when I'm saying that my null hypothesis is average marks is 80 and my alternative is it's not equal to 80. Okay, so there is a possibility after my test, after my statistical analysis, after me collecting the data, there is a possibility that the average score can be more than 80 or it can be less than 80. In both the cases, there are two conditions prevailing for me to commit the type 1 error. That is, I might accept the hypothesis. Okay, I might accept the I might reject the null hypothesis when it is not the correct answer, when it is correct. Okay, I am accepting the null hypothesis is the condition if the average score is 80. But there can be a condition where I can reject the null hypothesis when it is correct. So that possibility in a two-tailed test will be falling into these two parts, two ends. Me rejecting the null hypothesis when it is true. Okay, so that is what there are two possibilities. Me rejecting it because I anticipated that to be less, me rejecting it because I anticipated it to be more. So in two-tailed test, rejection region for two-tailed test in Z is a large sample test where we say that H naught, okay, our alternative hypothesis mu not equal to mu naught. Okay, so mu naught equal to mu naught with an alpha of 0.05 significance. So that is 5% significant. The decision rule is rejected. That is, we reject H naught if it can be the test statistics is less than or equal to or greater than or equal to this value. Now you might wonder from where did this is actually the value which I have taken from the Z table. See, in a two-tailed test, if the significance level, it goes like this, okay? It goes like, when the significance level is 5%, the value, the Z value is 1.960. And when it is, as you go, if it is 20%, 10%, 5%, 1%, like it will go like that. The value we take it from the Z table. Okay, that's how it's a statistical calculation which we get. So that is what we are going to put in this two-tailed test. So in nutshell, what you have to understand is when I'm not sure with the direction of the relationship, okay, when I'm not sure whether when I say that the average, the null score, null hypothesis, the average score is 80, I might be aiming that the alternative hypothesis can be less than 80 or more than 80. And my possibility of conducting this test is to prove that it is not 80. That's how we set the hypothesis. We always, a researcher would be looking into alternative hypothesis and into a condition where we are not, the test result do not support accepting the null hypothesis. So in a two-tailed test, we do not know the direction, whether it is less than or greater than. So in that case, we use this logic for accepting. So when I say there is 5% significance level, there is 5% chance of rejecting the null hypothesis when it is true. So the chance can be, it's like this. It is negative 1.96 or it can be positive 1.96, which I have taken the value from my Z table. Okay, so I have this part which is negative, which will be less than, or it can be greater than 80. That's what I try to prove a two-tailed test. Now, this is my accept region. This is my region where I can find that my alternative, my null hypothesis being supported. So in a two-tailed test, when I'm talking about this area, it will be 1 minus alpha. 1 minus alpha. Alpha is the probability of me risking the answer by rejecting the null hypothesis when it is true. So this region is represented as 1 minus alpha. It's very simple. It's logical, right? If I say these two regions are called as alpha, that is alpha, the value which I get here is nothing but alpha divided by 2. Okay, so when I say that this region is represented by alpha, of course, this value would be 1 minus alpha. So two-tailed test is used when we do not know the direction of the value. We do not know whether it is more than or less than. Maybe there are different types of hypothesis testing. It will be testing of mean, it will be testing of variation, that is proportionate variation, or it might be testing of relationship, like cause and impact, cause and effect, like that. So if that is the case, how do we explain that might be different, but the basic logic remains same. Suppose if I don't know the direction, I'll use the two-tailed test. If I don't know whether that is greater than or less than the mean which I have identified, I will use two-tailed test. So that's the condition. The first testing of hypothesis 1. Now level 2 and 3 is used when the researcher is somewhat sure about the direction. Okay, somewhat sure about the direction. So here the decision rule is reject the null hypothesis if the value is this 1.645. This is something which I've taken from the lower two-tailed test. Okay, I've taken from the lower two-tailed test, which is negative 1.645. This is already there in the Z table. So the possibility of rejecting null hypothesis at 5% in a lower tail test, or as you call the left tail test, okay, left tail test, then in that case it will be the possibility is this area. So here it would be 1 minus this value. This region is represented as, so here we know the direction. We are showing the direction that the null hypothesis is rejected at 5% significant level when the value of the test statistic is smaller than negative 1.645. Okay, there is a possibility that we will go with rejecting or committing type 1 error when this is how it is happening, 5% significance level at 5%. So there is a chance of rejecting the null hypothesis when it is true to 5%. And if it is we are talking about 1%, the value will become this. That's already written for all the tests. For Z test, the value will be like that. T test, the value is different. We will take it from the T table. Okay. So this is how we go with a left hand or left side, left tail test. Okay, and the opposite is with respect to the right tail test. So when we are talking about decision rule here, it will be, we will be rejecting H naught if it is greater than or equal to 1.645. Okay, so in this case, this is the region where there is possibility of rejecting the null hypothesis when it is true. That is, the alpha is here. So we were talking, when we know the direction, we will have either left tail test or a right tail test. When we do not know the direction, we will put the risk factor into two tail test. There is a possibility when the value is less than a particular thing. If it is 5%, we will say, okay, that's a value. But if it is 2%, this is the value. The possibility of rejecting when it is less than and when it is more than. That is two-tail test. Whereas when we are talking about the left tail test, I'm talking about, I know the direction, it is less. But when it is less than, smaller than negative 1.645, the risk is I might or there is a possibility that it gets automatically rejected by the, excuse me, rejected because of the calculation error, because of the type 1 error. Okay. And when I know the direction that it is positive, it is more than, so I'm talking about when it is greater than 1.645 at 5% significant level, there is possibility of commission of type 1 error. So I'll just go back to the previous one, repeat it once more. Level of significance is nothing but it is the probability of commission of type 1 error. Now, what is type 1 error? We know that it is rejecting the null hypothesis and accepting the alternative when it is true, and it is denoted by alpha. Now, the general use percentage level of significance are 5%, 1%, 10%. Suppose if I'm saying that there is chance of 50%, then there is no validity to my study because 50% means it is too high. Too high. I'm saying that the risk of committing an error is almost 50%. In certain researches, that might happen when the data, you do not get correct data, or when it is very difficult to collect data, likewise. But generally, we stick on to 5%. And if it is a very, the type of information needed should be very accurate, then you go with 1% significance level to give authenticity to the results. And then we talked about testing of hypothesis, where we talked about two-tailed test, left-tailed test, and right-tailed test. Right, two-tailed test is used where we are saying that the chance of committing the error. Okay, we do not know the direction, but there is chance of committing the error. And if it is 5% significance level, the value being identified, it is 1.960. And we say that if it is less than or equal to 1.960 or greater than or equal to 1.960, there is a possibility of commission of type 1 error. And this region is represented as the the correct one, which is the formula wise it is represented as 1 minus alpha. 1 minus alpha is the chance of committing type 1 error, and 1 minus the whole thing being 1 minus alpha. That is the representation to this part. Now going with the left tail and right tail, when I know that this is the direction, the value can go down, then I go with the left tail test. I find out the significance level. Here in this case, I've gone with using 5% significance level. And I've said null hypothesis is rejected at 5% significant level when the value of test statistic is smaller than negative 1.645. I say that there is a possibility. That's a possibility of at 5%. This is actually, this value is used when we go with the manual calculations. But when we are going with the software calculation for like Excel, or maybe we are using SPSS or any other software for calculation for testing of hypothesis, because when the data is huge, we go with statistical packages for calculation of hypothesis, testing of hypothesis like t-test or f-test or z-test or chi-square test. We go with that. In that case, we will look into p-value, which we will discuss in our tomorrow's class. But when you are manually calculating, we'll take the value from the table and go with the calculation. We will, is a table or whichever distribution we are using, we'll take the value from that and we will compare that. So now in this case, we are discussing about large sample size test, that is Z test, and we are looking into what will be the result. So if I feel that the value will be aligning towards the lesser part, towards the left, it's towards the negative part, then I say that the possibility is like this. But if I feel that the value can be more than this, the average, the example which we were discussing is 80 marks. The average can be more than that. I know the direction. I expect that, yes, PG students, they are very good in academics, so their average can be more than 80 marks. That's my expectation. So what I will do is I will be just aligning it to the right side, which is called as the right tail test. And I say that at 5%, there is chance of rejection when the value of test statistic is smaller than 1 point, it is larger than 1.645. So there is, the possibility which is anticipated here in this case is the value can be more when it is mean. Okay, but there is a slight difference when we are discussing from the angle of variance, or as we say cause and effect, which we will be discussing in our further classes. But from the basic thing, we will always be looking into average, or as you call us, mean. There we say that if I expect that there is a difference, and if I expect the difference to be more than 80 score, yes, I go with the right tail test. And the basic procedure which we will be looking into, okay, the basic procedure which we will be looking into for testing of hypothesis, as I said, the same example. I've given these steps with the same example I was mentioning when I was talking about level of significance. So the procedure for hypothesis testing is, first time I will set the hypothesis. In our case, the example which we discussed in the class, the hypothesis is that the mean, the average score of mark of PG student is equal to 80 marks. That's the average mark, which is called as the null hypothesis. And then I know if that is the null hypothesis, I can put the alternative hypothesis as average score. The mu naught is not equal to, the mu is not equal to mu naught, which can be greater or less than 80. And then the next thing what I will be doing is I will select a significance level. Now there are many factors that can guide the selection of significance level, because if a researcher finds that the data is not so, it's a crude data, it is not really representative of the population, or if the sample size cannot be increased beyond a certain level, there is a restriction to collection of sample. Because when we say that we can, if we come across type 1 or type 2 error, basically what we do is the chance of committing type 1 error is minimized by expanding the sample size, by increasing the sample size, making the sample more or less representative of the actual population. That's what every statistician will suggest if you have some trouble with the result. They might say, okay, if it is not representative of, or if you are not arriving to the right kind of conclusion, which is in reality, then what you can do is you can test further by increasing the sample size. So that's where we look into, okay, what is the level of significance level? So if the researcher is okay with the quality of the sample, the representation of the sample, he might fix the significance level at 5%, which means if he or she is saying that, yes, the results of the study to a percentage of 5%, there is a risk factor of not accepting as you say, the null hypothesis when it is actually the actual representation, when it is true. There is 5%. Suppose if in this case, maybe the average percentage of marks in the class is 80. Okay, that's a null hypothesis. So the chance of rejecting the null hypothesis is defined with 5%. There is 5% risk of rejecting it when it is true, when it is 80. That's what we call as significance level. And once we fix that, then we go with the test statistics. It's nothing but testing the statistics or data collected to come to or to arrive at a conclusion. Now, testing, the type of testing used will depend upon the type of distribution you are having in your hand, which can be, if it is large sample, we go with, we call as Z or F distribution, and when it is small, we go with T distribution. But normally, in a when we go with a software, we say that the sample should be large enough to go with the statistical analysis, because manually we can adjust many things. We can arrive at values which is representative of the actual condition. But for when we go with the software, the sample size should be large enough, should provide some kind of representation to the actual population. So the third step is selecting the test, looking into the distribution. It can be T distribution or F distribution, or it can be when you don't have all parametric, it can be non-parametric, and you might go with chi-square distribution also, which we will further when you are actually doing the research, you will come to know what are the situations where you are going with different types of test. But basically, test is decided based on the type of distribution we have it. And then based on that, we will have the critical value. As I showed, I showed the critical value which I had taken from Z table. Likewise, you will take it the critical value which will decide the possibility of committing the error. So, and then finally, this value is being compared with the hypothetical value. Hypothetical value means the value which either you've arrived at by taking the mean of the population. Suppose if the population is indefinite, you cannot define it, you cannot arrive into or find out a mean, then it is a hypothetical mean, which is being done by using formula, and you compare that with the test statistics, the result which you get, and we arrive at conclusion. So this is how we go with testing of hypothesis, which will become very clear only once you do it. Okay, because this is something which I'm describing where you are very new to this. But these are the steps which we would be doing when you are going with hypothesis testing. First is we set a hypothesis, which all of you have set it, and then you fix the significance level based on the kind of experience the researcher would be having, or based on the quality of the data which the researcher has got. And after that, the researcher will go with computation part, and decision is being taken based on the critical value. Manually, we go with that, we're looking into the critical value. But as I said, if it is in a software, everything will be done by the software, and we will be given with p-value to arrive into a conclusion. This is all about hypothesis testing. So I'll just go back to the